So Elise here from Advanced Quantitative Reasoning. Right now I had a request from this from, let me see, it was a person, forgot, here it is, Jana Proudmore. Alright Jana, this is for you. So we have this Extension 6, so, you were asking questions about this. Today movies are made in the theaters. You have these new aspect ratios right here, and so these are on widescreen, so that when you go ahead and actually show this aspect ratio on a 16:9 television, there's minor letterboxing. So in other words, if this right here was minor letterboxing, that would be like a little black line down here and up here. There's letterboxing at the top and the bottom. So first things questions, why are all identified as something to 1 or perhaps even recorded in decimal value? That's because it makes it a lot easier to go ahead and do a scale change, and you'll see this in just a few seconds. So express this in, let me see that. I gotta get. So you just take the 16, divide that by 9. That's 1.7, so we can go ahead and say this is 1.78 to 1. That's really easy right there for that question. A movie with an aspect ratio of 1.85 to 1 is shown on a letterbox image on a newer 50-inch 16:9 television. Calculate the height of the image, the height of barely visible black bar, and the bottom of the screen. So we're going to be doing a couple things here. Make sure you can see me right here. Yeah. So let's see. We have the 16:9 original image. This is the image. So right here we have a 50-inch television. So this right here is 50. So we have to find the width and the height of this particular television. It's really simple. I'm going to go ahead and use similar figures to do this. 16 squared plus 9 squared. Whoops, always hit the wrong button. Clear that. Whoops, that's not what I wanted to do. That's 9 squared equals that, square root of that, and that's 18.35. So we're going to use this to get at least our height, but our width is also necessary, so just get it, because you know what, you never know when you're going to need it. So let's see, I'm going to set this up. 18.35 divided by 50 is equal to 16 divided by W. So cross multiply, divide. So 50 times 16 divided by 18.35, 43. 43 point about 60. That would be about there. And then the height would be almost the same thing, except right here I'd change one thing. This would be 9 and this would be height, so just do the cross multiply. So 50 times 9 divided by 18.35. So it's 24. So this is equal to 24 point, I think I'm way off the screen. Oh no, I am, barely. 24.52. So that gives the height and the width of the screen. Now, just need to do this right here with the next part. So let me just redraw this. It just helps my mind the way I work. So let me go ahead and redraw it. I have the new screen. It's a 50-inch. I have 43.60 right here. You have 24.52. And this is all in inches. Sorry, I don't know how to scale sometimes, so I'm just working really fast, not really thinking about it. Okay, calculate the height of the image. Let's see. Barely visible black bar. Well, remember, we're going with this right here. And that. So, this is what you do. You set up the aspect ratio. So this right here represents 1.85 times x, and then 1 times x. So this is the way you need to think about this. the way we do the scale factor, if we go ahead and multiply 1.85 and 1 by the same scale factor, we're going to have an image that's bigger, that's going to be in the same aspect ratio as what we had originally. So right here, we want 1.85x, when you multiply that, you want that equal to 43.60. So I just solved for x. And this will give you the reason why this is so easy to go ahead and use. Why it's easy to use that 1.85 to 1 aspect ratio. 43.60 divided by 1.85 gives you 23.56 or 57. So that's equal to 23.57. That means that instead of multiplying by 1, you just need to say it's 23.57. It's no math. You don't need to worry about it. From there, you just subtract this from here. So 24. Let me see if you can see that. Yeah. So now it's 24.52 minus 23.57. 24.52 minus 23.57. That gives me 0.95. And since we have 1 at the top and the bottom, when you add it together, it has to be 0.95. So you divide that by 2. That gives me this little part right here equaling to 0.475 inches. 0.475 inches. So now you have all your information. So right here, if you look at it, a movie with an aspect ratio of this, blah, 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 and the percentage of the screen or the area occupied by the image. So, the height, and we need to get the percentage, so let's see, the percent of the screen's area that's occupied by the image. So all we need to do to get the percentage of that would be taking 23.57 divided by 24.52. We could get the area of the entire screen divided by the area of the image that it's occupying. But you know what? Your inches right here, this 43.60 is going to get canceled out inside the work. So why do you do it twice? So this will give us our percentage of the area. And this would be 23.57 divided by 24.52. That's approximately 96.13%. That's the percentage that's of the screen that's occupied by the image. And this right here is the height of the screen, height of the letter boxes. And the reason why it's so easy is because since you're multiplying by 1, all you need to do is solve for the x. And once you get that x, you have basically your height automatically. You don't need to worry about anything. Go ahead and message me on YouTube just in case you have any more questions. I'm not going to answer the second part because I'll leave that up to you, because I think you can go ahead and follow that because it's asking the exact same stuff. Except now we have a 4:3 television, and instead, let me see, find the height of the image. Yeah, you're going to have the same thing. It's the same thing. You're going to have this letterboxing, and that's what you're going to be using. Alright, see ya.